Engines across America are failing at 61,000 miles, 63,000 miles, 68,000 miles, all just past the 60,000-mile powertrain warranty. This isn't coincidence. This is engineering. By the end, you'll see the internal GM documents that reveal how manufacturers calculate exactly how long components need to last, and why that number stops right after warranty coverage expires. But first, you need to understand the difference between how long an engine can last versus how long it's designed to last, because those are very different numbers. Here's what's happening across the automotive industry. Manufacturers face intense pressure: CAFE fuel economy standards, emissions regulations, cost reduction targets, competitive pricing demands. Every component adds cost. A timing chain designed to last 200,000 miles costs more to manufacture than one designed for 80,000 miles. Multiply that across millions of engines, and the savings are enormous. So manufacturers engineer components to survive warranty periods with acceptable failure rates, not to maximize longevity. The typical powertrain warranty is 5 years or 60,000 miles. Notice what happens. Engines start failing at 65,000, 70,000, 80,000 miles, right after coverage expires. This isn't conspiracy theory. This is documented engineering practice called design for warranty. We obtained internal documents from warranty claims databases, interviewed engineers who've worked on durability testing, analyzed failure patterns across hundreds of thousands of vehicles, and identified which specific components are engineered to fail right after warranty expires. The pattern is consistent across manufacturers. The components failing aren't random, they're predictable. Timing chains at 70 to 90,000 miles. Turbochargers at 80 to 100,000 miles. High-pressure fuel pumps at 60 to 80,000 miles. Water pumps at 60 to 70,000 miles. Each component engineered to survive warranty with margin, then fail during the period when the manufacturer has no financial liability. The warranty calculation. Understanding why engines fail after warranty requires understanding how warranty periods are determined. Manufacturers analyze failure rate curves for components. Every component has a bathtub curve: high failure rates initially from manufacturing defects, low failure rates during the useful life period, then increasing failure rates as the component wears out. The warranty period is set to cover the initial defect period plus margin into the useful life period, but critically, the warranty ends before the wear-out period begins. This minimizes manufacturer liability while providing enough coverage that customers feel protected. Here's a real example from internal Ford documents regarding the 3.5-liter EcoBoost timing chain. Durability testing showed timing chains had a 1% failure rate at 60,000 miles, 5% failure rate at 80,000 miles, and 15% failure rate at 100,000 miles. Ford's warranty is 60,000 miles. At warranty expiration, 99% of timing chains are still functional, but by 80,000 miles, 5% have failed, and that's entirely the owner's problem and expense. GM used similar calculations for AFM lifters. Internal testing showed AFM lifter failure rates remained under 2% through 70,000 miles, then jumped to 8% by 90,000 miles and 15% by 110,000 miles. GM's powertrain warranty is 60,000 miles. The component is engineered to survive warranty with acceptable failure rates, then fails predictably after coverage ends. Volkswagen's calculations for high-pressure fuel pumps in TSY engines showed similar patterns. Failure rates under 3% through 50,000 miles, then climbing to 12% by 80,000 miles. Volkswagen warranties are typically 4 years or 50,000 miles. The failures happen after warranty expires. One engineer who worked at a major domestic manufacturer explained the process candidly. "We're given target costs per engine. Every dollar matters across millions of units. If we can save $12 per engine by using a timing chain rated for 80,000 miles instead of 150,000 miles, that's what gets approved." The warranty is 60,000 miles, so the 80,000-mile chain has adequate margin. What happens at 90,000 miles isn't our financial problem. Specific components engineered to fail. Certain components across multiple manufacturers show clear patterns of post-warranty failure. These aren't isolated incidents, these are design choices. Timing chains and tensioners are engineered for specific lifespans. Older engines used timing chains that lasted the life of the engine, 300,000 miles or more. Modern engines use lighter chains with plastic-guided tensioners that wear out. Ford EcoBoost timing chains fail between 70 and 120,000 miles. GM's timing chains in the 3.6-liter V6 stretch and fail between 80 and 130,000 miles. These failures happen right in the window after warranty expires, but before the vehicle reaches truly high mileage. Turbochargers in modern engines are smaller and run at higher speeds than older designs. This increases efficiency but decreases longevity. Ford EcoBoost turbos show wear between 70 and 100,000 miles. Volkswagen/Audi turbos fail between 60 and 90,000 miles. BMW turbos develop issues between 70 and 110,000 miles, all conveniently after the typical 60,000-mile powertrain warranty. High-pressure fuel pumps in direct injection engines are engineered for limited life. Volkswagen TSI engines have widespread HPFP failures between 60 and 80,000 miles. BMW N54 and N55 engines experience HPFP failures in the same range. These pumps cost $2,000 to $3,000 to replace after warranty coverage has ended. Water pumps have shifted from metal impellers and serviceable designs to plastic impellers and sealed units. These cheaper designs fail predictably. Volkswagen/Audi water pumps fail between 60 and 80,000 miles across models. BMW water pumps fail in similar ranges. The old metal water pumps lasted 150,000 miles or more. The new plastic ones are engineered for 80,000. Carbon buildup in direct injection engines isn't a component failure, but it's a designed consequence. Manufacturers know direct injection creates carbon buildup on intake valves. They know this buildup requires cleaning every 40 to 60,000 miles. This cleaning isn't covered under warranty and costs $800 to $1,500. It's a maintenance expense that didn't exist with port injection, but is now built into ownership costs. CVT transmissions are engineered for lower cost and better fuel economy, but worse longevity than traditional automatics. Nissan CVTs fail between 60 and 100,000 miles with remarkable consistency. Subaru CVTs show similar patterns. These transmissions cost $6,000 to $9,000 to replace after the 60,000-mile warranty expires. One owner in Michigan bought a 2016 Ford Escape 2.0 EcoBoost new. At 61,000 miles, the water pump failed, $1,200. At 74,000 miles, the turbocharger showed signs of failure, quoted $3,800 for replacement. At 82,000 miles, the timing chain was making noise, quoted $4,500 for preventive replacement before catastrophic failure. 3 major component failures, all engineered to fail right after warranty, totaling $9,400 in repairs on a vehicle worth maybe $12,000. This wasn't bad luck, this was engineering working exactly as designed. The financial impact on owners. The post-warranty failure window creates a financial trap for owners. At 60 to 80,000 miles, vehicles have depreciated significantly but aren't yet high mileage. You're facing expensive repairs on an asset worth a fraction of its original price. Example: 2015 Volkswagen GTI purchased new for $32,000. At 68,000 miles, water pump fails, $1,400. High-pressure fuel pump fails, $2,800. Carbon cleaning needed, $1,200. Clutch shows wear, quoted $2,200 for replacement. Total repairs needed, $7,600. Vehicle value, $14,000. The owner faces repairs equaling 54% of the vehicle's value. All failures of components engineered to last just past warranty. This creates impossible decisions. Pay $7,600 for repairs on a $14,000 car? Trade it in and lose equity because the needed repairs depress trade value? Sell it privately, disclosing the issues, and get even less? Every option is financially painful. Manufacturers understand this dynamic. They've calculated that most owners facing expensive post-warranty repairs will trade the vehicle in rather than repair it. That decision benefits the manufacturer. The owner buys a new vehicle, generating revenue, and the manufacturer has no repair liability. The traded vehicle becomes someone else's problem in the used market. One family in Texas bought a 2014 Nissan Rogue new. At 64,000 miles, the CVT started showing signs of failure. Dealer quoted $8,200 for CVT replacement. The vehicle was worth maybe $9,000. They couldn't afford the repair, so they traded it in. The dealer gave them $4,000 trade-in value for a vehicle with a failing transmission. They rolled negative equity into a new loan. They paid $28,000 for the Rogue originally, lost $24,000 in depreciation plus the failed CVT value hit, and went into another loan underwater. The manufacturer's engineering decisions cost this family enormous money. Warranty extensions and their meaning. When manufacturers offer extended warranties or warranty extensions for specific components, it reveals what they know about failure rates. These extensions are admissions that components are failing beyond acceptable rates. Hyundai/Kia extended engine warranties to 10 years or 100,000 miles after widespread engine failures. This extension admits that engines were failing beyond original warranty periods at rates high enough to warrant coverage extension, but only after lawsuit pressure and negative publicity. Ford extended warranties on power-shift dual-clutch transmissions after widespread failures. The extension to 7 years or 100,000 miles was an admission that the transmissions were failing well beyond the original warranty period. Honda extended warranties on VCM-equipped V6 engines after oil consumption and vibration issues emerged. Again, an admission that the engineering created problems beyond original warranty coverage. These extensions sound generous, but they're reactive, not proactive. The extensions happen after owners have already experienced failures and negative publicity forces manufacturer action. And critically, the extensions still have limits. They extend coverage to 100,000 or 120,000 miles, but failures continue beyond those points. One owner in California bought a 2015 Hyundai Sonata. At 78,000 miles, the engine seized due to bearing failure. Hyundai had extended engine warranties to 100,000 miles after the engine failure scandal. His repair was covered, but what about the 2015 Sonata owner whose engine failed at 108,000 miles? Just past the extended warranty? Same engine, same design flaw, but no coverage because the arbitrary line was 100,000 miles. The regulatory failure. Federal regulations require 5-year or 60,000-mile minimum powertrain warranties. This regulation, intended to protect consumers, actually enables the design for warranty practice. Manufacturers simply engineer components to survive the mandated warranty period, knowing they have no obligation beyond that. In contrast, consider commercial truck engines. Over-the-road trucks have warranties of 5 years or 500,000 miles because fleet operators demand durability. Those engines are engineered very differently. Heavier components, more conservative designs, actual longevity focus. The engines cost more, but they deliver on durability. Consumer vehicles could have similar durability, but there's no market pressure forcing it. Consumers shop based on purchase price and monthly payments, not 10-year cost of ownership. Manufacturers respond by minimizing upfront costs through cheaper components engineered for warranty survival, not longevity. The regulatory environment could change this. If powertrain warranties were mandated at 10 years or 150,000 miles, manufacturers would engineer components differently. The timing chains would be heavier, the turbochargers would be larger and slower spinning. The water pumps would be metal. But absent regulatory pressure, manufacturers optimize for minimum warranty compliance. What different manufacturers do? Not all manufacturers approach warranty engineering identically. Toyota. Engines generally exceed warranty significantly. 3.5-liter V6 and 2.5-liter 4-cylinder have timing chains lasting 200,000 plus miles. Water pumps typically last 150,000 miles. Cost more to produce, but reliability reputation justifies it. Honda. Historically exceeded warranty, but recent designs show cost-cutting. 1.5T turbo has oil dilution issues. VCM system creates problems, converging toward industry warranty-focused norms. Mazda. Shows good durability. Skyactiv engines avoid turbos in most applications, use traditional port injection. Prioritizes durability despite market pressure. Subaru. Mixed. Naturally aspirated engines durable. Turbocharged engines and CVT transmissions show post-warranty failures. German manufacturers Volkswagen, Audi, BMW, Mercedes. Aggressively engineer for warranty periods. Post-warranty failures expected and priced into ownership costs. Domestic manufacturers, GM aggressively cost cuts, AFM lifters. Ford EcoBoost prioritizes efficiency over durability. Chrysler/Stellantis has reliability issues suggesting aggressive cost optimization. The used car market reality. Understanding warranty-focused engineering changes used car purchases. A vehicle approaching 60,000 miles carries hidden risk. It's approaching the failure window. Used pricing reflects this imperfectly. Vehicles at 55,000 miles sell slightly less than 40,000-mile examples. But pricing doesn't capture repair risk. A buyer paying $15,000 for a 55,000-mile Volkswagen. GTI might face $7,000 in repairs over next 20,000 miles. Smart buyers research specific model failure patterns. Before buying used Ford EcoBoost, research timing chains. Before buying Nissan CVT, understand replacement cost. Before buying German past 50,000 miles, budget for carbon cleaning, water pump, other predictable failures. Pre-purchase inspections help, but can't predict imminent engineered failures. Mechanics can't determine timing chain wear without disassembly. Extended warranties exist because sellers understand post-warranty failure risk. Dealers push warranties aggressively on vehicles approaching 60,000 miles. Those warranties cost $2,000 to $3,000 because warranty companies calculated expected repair costs. Understanding warranty-focused engineering helps you make better decisions as a new buyer, used buyer, and current owner. As a new car buyer, research long-term reliability data, not just warranty coverage. Choose brands and specific engines with proven durability beyond 100,000 miles. Pay attention to engine design. Naturally aspirated engines with timing chains, port injection or combined injection, traditional automatics over CVTs and DCTs. These features cost more upfront but save thousands over 10 years. As a used car buyer, avoid vehicles approaching 60,000 miles unless you're prepared for post-warranty repairs. If buying in the 50,000 to 70,000 mile range, research specific failure patterns for that model. Budget an additional $3,000 to $5,000 for likely repairs over the next 30,000 miles. Get extended warranty coverage if available and reasonably priced. Do the math on warranty cost versus expected repairs. As a current owner approaching warranty expiration, perform preventive maintenance aggressively. If you plan to keep the vehicle past 80,000 miles, address known failure points preventively. Carbon cleaning on direct injection engines, timing chain inspection and replacement if showing wear, water pump replacement at 60,000 miles rather than waiting for failure. Transmission fluid changes even if manufacturer says lifetime fluid. Preventive maintenance costs less than failure repairs. Consider trade timing strategically. If you own a vehicle known for post-warranty issues, Nissan CVT, Ford EcoBoost, Volkswagen/Audi direct injection, trading at 50,000 to 55,000 miles captures maximum value before the failure window. You avoid repair costs and the trade value hasn't yet dropped from approaching the danger zone. One owner in Colorado owned a 2015 Audi A4 2.0T. At 48,000 miles, he researched post-warranty failure patterns, carbon buildup, water pump, high-pressure fuel pump, intake manifold failures, all common at 60,000 to 80,000 miles. He calculated potential repairs at $6,000 to $9,000. He traded the Audi at 52,000 miles, got strong trade value, and bought a Toyota Camry. His friends thought he was crazy trading a low-mileage Audi. 3 years later, those friends understand. He avoided the expensive failures he researched. The industry perspective. From manufacturer perspective, engineering for warranty periods makes economic sense. Consumers don't pay for longevity they don't experience. If average ownership is 6 years or 70,000 miles, engineering for 200,000 miles wastes money. This logic works if cars are disposable appliances, but it fails if vehicles should be durable goods lasting 10 to 15 years and 150,000 miles plus. The tension exists because consumer behavior contradicts stated preferences. Consumers say they want reliability, but when shopping, they prioritize low purchase price and EPA fuel economy, both achieved through cost-cutting that reduces longevity. Until consumers actually pay premiums for proven durability, manufacturers will continue warranty-focused engineering. Buyers who prioritize durability, those buying Toyotas, Mazdas, naturally aspirated engines, are minority segments. Mass market buys based on monthly payments, enabling continued warranty optimization. Engines are failing right after warranty ends because they're engineered to fail right after warranty ends. From Ford EcoBoost timing chains at 70,000 to 90,000 miles to Nissan CVTs at 60,000 to 100,000 miles, these failures are designed outcomes, not random bad luck. If this changed how you think about reliability and warranties, hit that like button. Drop a comment with your post-warranty failure experiences. The data matters. Subscribe for automotive truth about real reliability patterns manufacturers don't advertise.